Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! As you can see, 283 amp is zipping along, and I'm excited that this is probably going to be a really good template to use for almost any kind of direct heated triode, whether it's a 300B or a 45 amp or 283, any of that stuff. And we just happen to be doing this as a 2A3. And there's a couple of little things that I'm learning as I'm going along that I may do a little different. That's why you do a prototype. And yeah, but this is turning out good. And I'm waiting for some iron to come in from Musical Power Supply to do the 300B version of this. But anyway, let me show you what we're doing as far as the chassis layout, kind of fab work, and some other details on building one of these amplifiers. So let's get busy. So let's look at how the 2A3 chassis fab's going, and we're almost done with it. And I'm realizing that this could actually be kind of a universal direct heated triode amplifier chassis layout, and potentially even for something like a KT88 build. So what we've got here is, in this back corner we have the power transformer, and we've got the two grommets, the 4 holes drilled. Here's the choke in the front. We have a grommet here, the 4 holes, rectifier tube, vent, output tube, 2 driver tubes, and then the output transformers here in the back. And the hole pattern for the output transformers, of course, would change depending on what output transformer we're using, so that's not a big deal to lay out. But the rest of this could be used, like I said, pretty universally. And I did figure out how to mount this kind of generic voltmeter here in the front, where I think it looks nice. It hides most of the plastic of the meter underneath, and with some spacers where just the top part of it sticking up, I think it looks nice. In the future, I could try to hunt down a trim ring to go around it and get them fabbed up with some holes drilled in them. Might actually look at seeing about finding somebody that maybe could even manufacture those, because I think there's a lot of people that would like to use these budget meters, but they're just not very attractive. And if it had a trim ring that came out to like this far, and then had 4 3mm screw holes drilled in it that would hide the screws, and was like made out of silver anodizing, I think that would be a really cool thing. So anyway, for now, we're just going to put some little Allen button head screws to hold that down. So you may have noticed on these holes here that there's a little tab left. And that's to use these type of tube sockets that have these indexing grooves in them. And then you can put it in and they won't rotate. And then you attach them from the underside with these little split retaining rings that are wave shaped, and they hold it in place. And I've used these before, but I didn't have a way to leave this little tab to index them. And I found this chassis punch that has this groove in it, and then it's got this other piece here that will punch a hole and leaves the little groove here for the tube socket. So we're going to use those in all the tube sockets, and I have these in both 8-pin like this, and then I also have some that are in 4-pin like that. And they make them in 5-pin, 6-pin, 7-pin. I've seen them in almost every configuration. This is kind of old school way of mounting tube sockets, but I like it because it doesn't have any hardware visible on the top. So it's a really clean look. and then we're going to come back and put the trim rings around these and use the holes that we drilled to mount them to hold the tag strips on the underside of the chassis, so that the only visible screws will be the ones holding down the transformers and then the ones around this meter. And I also sat down, I've had a lot of requests for this, and I'm going to put this on the website. I sat down in Photoshop and created this pattern. Gonna publish it as a PDF, and when you print this, just make sure you print this in the actual size. Make sure you pick that selection in your Adobe Reader, and then let me show you how nice this works. It is the exact size of these trim rings, as you can see. And what you do is you can drill a small hole, like a 1/16 of an inch, in the chassis where you want to center up this pattern. And then there's a little dot here in the center. You can hold it up with a light behind it, and you can center this dot on your pilot hole. And then tape the pattern down, and each one of these little holes has a little tick mark in the center of it, and you just come in with your center punch and mark each one of these, and then drill these holes out. And you have this really nice looking vent pattern around your tube socket. And I think they're a really nice size. They leave enough metal between the holes, and then when you put the ring in, you can see the holes are right at the edge of the inside diameter of that ring. So even if you're using like a KT88 tube that has a larger base, it doesn't block the holes. And like I said, I'll be putting that PDF on my website soon. So you guys that have wondered how to do this fab work, that'll make it a lot easier for you. And again, this turned out really nice, and it turned out that nice. I found this giant punch on Amazon, and this was actually pretty cheap. I think it was like 35 bucks, which is telling me this probably isn't made out of super robust material, but it's a 45 millimeter punch, and it didn't have any trouble punching through this material. The trick to using these is every time you use them, put some heavy duty grease on both the threads. You want to put it underneath the screw head and the washer, which kind of stuck there. It is. Make sure there's grease on both sides of this washer, and then put grease all over these cutting surfaces so that as it's being pulled through the metal, it's lubricated. And that's one of the keys to making these things cut smoothly and last. Secondly, don't put a electric tool on this screw, some kind of impact gun or something. That's just going to destroy the tool, and it's probably going to destroy the chassis too. Turn it real slow, especially one this large, and just take your time. When it feels like it's getting tight, I would even back off, and that kind of lets the grease get back between the surfaces, and then continue on. You can see I got grease all over the thing, and I saw on Amazon people saying, the first time I used it, these edges got all dull, and I can see it took a little bit of abuse, but I think for the little bit that I'm going to be using something like this, it's going to work fine. In the future, if I'm going to end up doing a lot of this, I might try to find a better quality one, but you can see it punches out, thing like that. And then I also have a 19 millimeter punch that I use to punch the center hole for this big bolt to go through. And it's also used for punching the hole for the power switch on the front. And it also makes a good size for a 9-pin socket if you're doing a chassis that uses those. So then here on the front, we've got, you can see the hole for the power switch, and there's the D-shaped hole for our audio note volume knob. You drill a hole and then get a Dremel tool to make it an oval like that. And then on the back, let me go ahead and pull this meter up before we mess it up. And then you can see on the back, we have our RCA jacks down here. This transformer has 4 and 8 ohm jacks, and so, or taps, and so we're going to have a 8 ohm, 4 ohm, and there's the ground or common, and then common, 4 ohm, 8 ohm. And then the notorious IEC connector in the corner. What I do with these now is I mark the square, then I punch with a like 16th inch or 8th inch drill bit, put a hole in each of the corners, and then I come back with a Dremel tool that has one of these little cutoff wheels like this on it, and saw between the holes, and then I come back with a file, and you can see on this one I kind of left these upper corners because, yeah, didn't have to go up there because the trapezoidal shape of the actual IEC connector, which looks like this little guy right here. You can see it's got a little hip roof on the top, so you don't have to do these corners if you don't want to, or you can, it doesn't matter. You just want to make sure that this little thin lip here hides whatever cutout you do, so you don't have a lot of fudge room there, and it's better to cut this hole a little small and then come back with a small flat file and square up the hole. So that's all the chassis fab work. And then we got our little switch that's going to sit here. It's going to be a little 2-position center off. We're going with gold trim, so we got a little gold switch. And in the center off, it's going to be nothing, and then you can measure the cathode voltage on one tube and the cathode voltage on the other. I decided to not worry about trying to measure like milliamps. I know what the cathode voltage should be, and like on this amp we're shooting for 45 to 47 volts. So in that case we got a 0 to 50 volt meter, and as long as it's between 40 and 50 volts, we know we're good and the tube's working like it's supposed to. And yeah, I'm sure there's a way to calculate that up, but to me the simplest thing seemed to be just to measure the voltage on the cathode, and that tells you like how the tube's doing. So let me show you what we did with the power transformer, and it's something I do with all these Hammond transformers that have extra taps that I'm not planning on using. And I'll show you on this side first. This is a 300 series transformer that has all these taps that are like 110 volts and 115 volts that we aren't going to be using, so you could wire them up in series to be like 230 volts, or you could wire them up in parallel to be 115 volts or whatever. I'm wiring this up to be 120 volts, and so let me zoom in here so you get a little better view of this. And so they told me, if you look at the actual little chart that they make, it shows you which wires you need to tie together to get what voltage. Like I say, this is showing you the colors for all the taps that are on this transformer. So you can see we got a bunch of different taps. This chart shows you how to wire up for 120 volts, and they have these separate little charts for every country or every voltage that you want to use, whether it's 240 or 220 or whatever. This is a kind of a universal one. But as you can see, we're going to tie the blue and the black together, and that's one leg of the 120. And then we're going to tie the brown and the white together for the other side of the 120. So it's brown and white and black and blue. And so what I did here is I tied the white and the brown together right here. This is the white and the brown. You can't, they got a little, this black paint on it. But anyway, trust me, this is the white and the brown. So I tied them together here. So we just have this one white wire coming out. And then we did the same thing here. We tied the blue and the black together. And then I just have the black wire coming out. So the white and the black is going to be our 120. And it makes the inside of the amp a lot neater just having those two wires coming out. And then we can go ahead and twist these up where they come out of the transformer like that. So the other thing I did is this little gray wire right here is the internal shield, or the electrostatic shield they call it. That helps just internally shield the windings, and so you want this connected to the chassis ground. So originally this wire was connected to this screw here, but that's assuming that the end bell is going to be grounded to the chassis, and I'm not sure how well that connection is going to be made. So I extended that wire out so that this can connect to our star ground point in the amplifier to make sure that the transformer shielding is grounded well. These are all the ones I didn't need, so I just cut them off and put a little heat shrink tubing on it and squish the end of them to make sure they don't short out to each other. And that's all going to be covered up in the end bell. So instead of having 10 wires coming out, we've got these 3. Now on the other side, we're going to end up using most of these. And the only ones we weren't going to use were the center tap for the 5 volts for the rectifier tube. We're not going to be using that because we're using an indirectly heated rectifier tube. And then this was the purple wire that's the 50 volt AC tap that you would use for a fixed bias supply. And we're not using fixed bias, so we don't need that wire either. So we just cut those off and heat shrunk them off. And then still got a pretty big bundle of wires on this amp coming out. But it's including 2 separate 2.5 volt heaters, which are like these red with the white wires. And then it's got the 5 volt for the rectifier heater. It's got these green wires, or a center tapped 6.3 volt for the heaters. And then there's another pair of wires here that is the, I think it's these black with the yellow stripe. They're the other 2.5 volt heaters for the output tubes. So cool transformer. It's got all the, additional windings we need for doing a direct heated triode. So, and then the other thing I do is I put the Hammond sticker that's on the top, I stick it on the bottom of the transformer, because obviously to me it would be ugly to leave that on the top of the transformer, and I still like to have it on there in case somebody is repairing it in the future. If they take the transformer off the chassis, the sticker will be there that tells all the color codings for the wiring and what kind of transformer it is. So, last thing that I've gotten done is I started working on repainting the end bells. And I did paint the laminations on the output transformers that were kind of ready looking. I painted them with some satin black so they match these Hammond nice black laminations. And then here is the end bells, and these are the ones that came on the musical power supply, and you can see how shiny these are. There's some kind of zinc plating, or almost chrome-like plating, and paint does not stick to these. And I tried scuffing them off with some sandpaper, and the paint still just flaked off. And so I ended up taking them over to my buddy's shop and bead blasting them, where they get a tooth to them so that I can prime them and paint them, and that seems to work well. These are a little different finish. They're a little duller, but I was still concerned that the paint wasn't going to stick to this very well. And so I am going to take these off and get these bead blasted too, to make sure the paint finish sticks and doesn't chip off super easily. And we're using the Krylon dark bronze hammer finish paint, which I think looks really nice. And I do have the transformer end bells painted, and this is what they look like finished. And I think it's a really nice finish. It's got, kind of hard to see in this, but it's got a little bit of metallic in the paint, and it's got this kind of coarse hammer finish, but they're pretty glossy. And I usually, after I let the paint dry for a couple of days, I come back with some cleaner wax that's got a little bit of abrasive in it, and it takes, if there's any kind of minor imperfections or variations in glossiness, it'll smooth them out, and waxing them helps protect the paint. But I like to give them about 48 hours before I do that. One thing I'll warn you about is if it's really humid, this paint will blush like crazy, and it'll have, it'll dry with like this chalky white finish. Sometimes, or most of the time, that'll buff out, but it's better to not have to deal with that. So try to avoid painting on super humid days, and it does help to put them in the sun and try to do it on a sunny day where you can put them in the sun after you paint them, not before. You don't want to get them like super hot and then spray the paint on them, because the paint will just flash on it and it'll be all, it's not pretty. It'll be really, I guess, pixelated looking is a good way of putting it. It's real, kind of crunchy, crinkly looking. That's very uneven. And so you want to paint these when they're fairly cool, but then put them out in the sun so that this paint dries fairly quickly, so it maintains this kind of rough hammered finish. Because if you let it dry too slowly, it'll just flatten out into like glossy, and that can look weird because it's all uneven. But I think it turns out really nice looking. So we're going to get all the iron painted this color to match, and then I do also replace, they come with this silver zinc plated hardware, which I think looks terrible. Maybe it's an aesthetic thing. And I've gone to the hardware store and I get replacement bolts that are the same size in black oxide. And then if they're extra long, like these may end up being, I trim them off on the end and then get something like my little black paint marker or some sort of, semi-gloss paint and touch up the ends after I saw them off. But I mean, this is just some of the attention to detail I do when I'm building amplifiers for myself and customers or anybody. I try to make them look as nice as I can, and it ends up being a lot of work. I mean, even just painting these end bells, I mean, I could just have left these black and then painted these black. It probably would have been the easiest thing to do, but I think this finish looks so much nicer, and it gives the amp kind of a unique look. And I think it looks good. It'll look good with this gold trim, and it also looks good with the silver. So at this point, I need to finish getting the transformers all painted and get them screwed back together, get the transformers mounted, and then we can start wiring up the power supplies and start figuring out where we're going to mount these tube rings. Because these threaded holes that mount them, I need to figure out where the best place for these holes to be so that the tag strips are in the right place. And I've got some parts coming from Mauser that should be here this week, and probably going to wait till some of that gets here and figure out how I'm going to do all that. But like I said, I think this whole little thing that I'm doing could really end up being kind of like a universal layout for doing both 2A3 and 300B amps. And the main difference would be that the 300B amps would have rectified DC heaters versus the AC heaters on a 2A3, which honestly isn't a huge difference. And of course they'd need different output transformers. So anyway, that's kind of where we're at. So this looks like a great place to wrap up this video. Well, I hope you enjoyed this segment on building this 2A3 amp, and I know I'm not doing as much on camera as I have in some other videos, but I really need to get this thing knocked out, and hopefully you can go back and review some of those other videos for like basic hole drilling kind of stuff. And like I said, I'm going to put this PDF of these vent holes for the tube socket on my website, and I think that'll make that a lot easier doing that fab work. And on the chassis punches, look on Amazon, look on eBay. Sometimes it's better to buy a higher quality used one if you can find them. But there is some investment in this. Even if you're planning on just building one amplifier to do the fab work, you're going to have to invest in some tools. And I know people have asked me in the past about, would you build me a chassis? And it's just so much work. It's honestly probably at least half of the time that it takes to build an amp, if not more, is fabricating the chassis. And if I did them, there's no way they'd be cheap. They'd be probably a quarter of the price of the amplifier for a fully fabricated chassis that's ready to go. And that's why I don't do kits, because doing a kit, boxing it all up, making sure everything's in there, and then writing up instructions and all that is honestly more work than building the amplifier, and it's half the fun. So anyway, hope you found this entertaining to watch. If you're enjoying this content, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters and members of the channel, down here somewhere, and you folks that subscribe. I want to try to hit 20K subs this summer, and I know maybe haven't had quite as much content lately, but I've got a lot of stuff going on. This is my last year on the city council elected office here in Doraville that I'm dealing with, and I'm trying to get some stuff wrapped up that I've been working on for years, and so that's going to keep me kind of busy. And so yeah, let's get this little 2A3 amp. And until the next video, have a nice day.